Hi. Okay. I pre-drew things out. But we are doing number 4 today. Given a linked list, check if the linked list has a loop. There is a cycle. Linked list can contain self loop. So much simpler than number 3. Like took me uh like 30 minutes to understand, whereas number 3 took me about 3 days to friggin' understand the solution. So um, let's get into it. So how it would work if we wanted to do it in a linear time is traversing through the linked list and adding it to a set. And in Python, you could store the memory addresses of each node, and in sets you were only allowed one unique item, and um, that's how we'll know if we have a cycle repeated linked list node, because in cycles we would visit the same item twice, and then we'll immediately return and go, okay, well, there's a cycle in here. So yeah, we're doing cycle detection. um, so that solution using a hash set will be linear linear space, um, and but the time complexity is the same for all solutions because it requires one transversal through. So no matter what, so there's different ways of there's different implementations of cycle detection algorithm, and I think what I've seen different strategies, and a very common one is having a slow pointer and a fast pointer. We have used the slow pointer and fast pointer techniques before. I have, at least, for the exercises, the other sets of Cal's algos. So this is not new. But yeah, so um, so we will talk about, it's called Floyd's tortoise and hare. Um, and what it can do is detect if there is a cycle. Oh, it does it in um, it does it in no, not linear. It does it in constant time. So, oops. Sorry, my husband walked in. I will continue. Don't remember what I was saying before my interruption, but we are doing. I really don't remember. We are doing cycle detection, and we're gonna use the good old algorithm of a fast pointer and a slow pointer, and the slow pointer will eventually, if it's a cycle, catch up and land in the same place as the fast pointer, and that means that it's a cycle. And if not, then we just break out and return false after when fast hits the null point or whatever, end of the linked list. Yeah. Yeah. Okay, I'm back. Interrupted again. But I remember where I was. So we're going to write the code, and I'm gonna draw it out, and then we're gonna do that thing that we do so well, which is talk about space time. No, we already did. Never mind, we already did. So I just came back. We already did. We talked about it. Okay. So the solution that we're going to do um, is called turtle tortoise, sorry, tortoise and hare. I don't know, I call it turtle, but yeah. So we're doing slow pointer and whatever cycle fast pointer, and we're going to do a head here, and um yeah, I think that's it. And sorry. Oh, this is a mess. Let me just write it over and write it well. Oh, blah, 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 blah. I should probably erase the. I should probably erase this too. And God, this is going to be the code up here. Blah, 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 blah. Blah, 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 blah. Okay. I'm gonna write it bigger. Oh, sorry. I hit the end of my tablet and I didn't know. And just gave out. Yeah. Blah, 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 blah. Okay, and we're going to have a slow and a fast pointer, both pointing to head. And we are now going to have a while loop that states while fast and fast dot next is not known, then slow equals slow dot next. So we are so as long as there's a fast pointer and the fast pointer has a next pointer on the fast pointer, we are going to increment slow by 1 and fast by 2, which is written as fast.next.next. Oh, my tablet. Next. I will say I've gotten much better at writing on my tablet than before, so I think this is good exercise for me. So yes, I like these exercises, and it's very simple. So eventually, the slow, if it ever catches up with the fast, you know we have a cycle, because it otherwise would never be able to catch up with the fast. They would never just be able to land. The slow would ever forever be behind. So it's just simple as that. And that was kind of the solution I initially thought of. I did not know that there was a professional term for it that called the tortoise and the hare. But I was like, well, you know, if something's in the cycle, it'll come back. So just, uh, find which one comes back. So my thing was using the hash set solution. Oops, I just realized I wrote the wrong time complexity. But for the solution. But yeah, my first thing was, I didn't think of using hash sets. I thought just using a dictionary, which yeah. And then the moment like there's a count of 2, then we like go, okay, well there's a cycle here because it should never return to that spot. But yeah, this one where we use a slow pointer to kind of tell is also really brilliant and so simple. So yeah, so if slow meets fast anywhere, then we could just go, okay, return true. Oh, with this solution we also know we know where the like if we know with the solution we know the existence of cycle, duh, and we know the where the what's it called, the first, not the head node, the first, the starting of the cycle starts. So we know where cycle began or begins, sorry, present tense. And we know, because we need to loop back to it, we know how many this nodes are in the cycle. So how long is cycle. So that's what we know. So we can return other things, but yes. And then if it never returns true, um, then we just come out and just return false because we're eventually going to reach the end of if it's not secular if it's not in a cycle, then we're eventually going to hit the end of something, in which case we're just going to return. And then when we hit um, the end, then we will return false. And we want to tell Python that it's going to be a true or false. So either true or false. We don't need to know where the last whatever is. We don't need to know how long the cycle is. We just go, is there a cycle? Yes, no. And that is a solution, and it can be done in constant space because we're not creating any additional structures with the slow and fast pointer. And it's in linear time because we need to go through it one time with 2 pointers, but just one time through the linked list. Okay, cool, bye.